You have the opportunity to upvote any questions as well, the ones that you find interesting, and then I'll leave 10 to 15 minutes at the end of the panel in order for panelists to answer these questions for you. Perfect. So let's begin. We have Anne. So Anne is working at Rolls Royce as a manufacturing engineer, manufacturing engineering manager of Global Test. He's also the founder of More Than 3D, which is a limited company specializing in design for 3D printing and production of 3D printed models. Next, we have Scott. Hello. Next, we have Scott. Scott is the Vice President of Business Development and Strategy at Keselowski Advanced Manufacturing, or CAM. He has an extensive experience in additive manufacturing, including leading teams in research and development in this field. And then finally, we have Caitlin. Caitlin's responsible for business development at Carpenter Additive, a fully integrated metal additive manufacturing partner. She also has extensive experience in the aerospace sector specifically, and in overseeing cross-functional teams in additive manufacturing. So the first question I want to ask all of you, just to grab everyone's attention a little bit, what was the most exciting project that you've worked in, additive manufacturing project, and how did that demonstrate the benefits of additive manufacturing in aerospace? And if we start with you.
Yeah, of course, yes. So, well, to be honest with you, I've worked on many interesting projects over the years. A lot of them I cannot tell you about because, you know, NDA, and, you know, it's not something I can talk about publicly. But the good thing is, you know, because I also run a company in my own town, which is More Than 3D, like Celina have mentioned about. And I do design and make a lot of educational models, and a lot of them are related to aerospace. So last year I did this very interesting project, which I and the team has made the world's largest 3D printed jet engine model. So our intention was, you know, to take the model on a road trip across the UK, and we was going to use the model to showcase to the young children, you know, how exciting 3D printing can be, and, you know, we're going to use that models to show the children how jet engine works as well. However, because of COVID, you know, we still haven't been able to do that yet. So it's still in a lock at the moment in one of my friend's house. So hopefully, you know, when COVID is over, we'll be able to take it on a road trip and to be able to showcase it to everyone.
Thank you. How additive manufacturing, how the development of the technology has really helped us in things like education as well. Yes. Scott, one for you. How has additive manufacturing improved since you first started working with the technology? And does that give you hope for the future?
Yeah, absolutely. I mean, you know, I've been in this industry almost since the beginning of it. So seeing, you know, SLA technology and everything that we've gone through with that, you know, through FDM, thermal jet, all of the tries at doing metal parts, and then, you know, laser powder bed fusion coming on the scene. It gives us a lot of hope for the future. You know, I used to have a pretty extensive background in polymers, and I turned away from that essentially into metals because of the future that I can see in laser powder bed fusion. So, you know, seeing what companies are doing with it and how we're advancing through it, you know, with better properties, and, you know, we're starting to have design allowables and, you know, things that are helping us get into production using this technology gives us a lot of hope for the future.
Perfect, thank you. And now if we focus more on the design of additive manufacturing parts, and I know you work at Rolls Royce, how does additive manufacturing help us in jet engine design specifically?
Massively, actually. So the thing is, you know, when a lot of people, you know, at Rolls Royce hear about 3D printing or additive layer manufacturing in the first place, all they can think about is, well, you know, we're going to use this technology to, you know, make future parts for our future engines, which is actually the case. So in Rolls Royce, you know, like we liaise with a lot of university, you know, to really push the technology to have us produce parts for parts for our engine in the future, which is something that we heavily invested in the company at the moment. Because what you can think about is, as for example today, right? I think a lot of people have heard of the term design for manufacture or design for assembly, which means whenever you design something, you have to keep in mind that you have to be able to manufacture the parts, or you have to be able to assemble the parts once you manufacture them. And if we only use the traditional manufacturing methods that we're using today, then you have a lot of boundary, a lot of constraints. What 3D printing technology allows us to do is think outside the box. Think about all the application, all the design that we were not able to produce in the past. So it really have us to think about how we can design this particular part differently, because we don't have the design constraint anymore. Well, there's still some constraint when it comes to additive layer manufacturing, but now it opens a new world for us to think about, can we push the design a little bit further now to make the engine more efficient, rather than constrain ourselves in what we manufacture today. And also, apart from making additive layer manufacturing, there's also massive application that we use at Rolls Royce as well. For example, the parts that we make on our current engine today using traditional methods, what can we do using additive layer manufacturing to have us make them better, faster, cheaper, for example. So at Rolls Royce, when we talk about manufacturing, it helps us reduce risk, reduce lead time, and mitigate risk. So those are the three key benefits that we see from additive layer manufacturing, especially when it comes to tooling design, validation of tooling. Traditionally we had to wait for months and weeks, to get a special tooling to have us manufacture parts or assemble module, for example. And sometimes, when it's not fit for purpose, but we couldn't see it, in the first place, because there was nothing for us to try. Nowadays, with additive layer manufacturing or 3D printing, we can just simply print a tool and validate the design before we can actually make one. And it helps you mitigate risk right at the beginning as well, rather than having to wait for weeks and months, and then you have to go back and change the design or modify the design of your tools or fixture. So I think there's a lot of areas that we can think of, and we're actually using additive layer manufacturing in many different areas in Rolls Royce at the moment.
Absolutely, yeah, it really adds a new layer of flexibility to our designs. Perfect. Thank you. And Caitlin, focusing more on a production point of view, what are the main benefits of additive manufacturing in aerospace, but also what are the blockers that we have today in the production?
Sure. I mean, I think for the most part, the industry is really looking for the biggest benefit to be cost right now. Still, we see a lot of customers come in and want there to be a significant cost savings over a traditional manufacturing method. The reality is that can be a benefit, and there's certainly some winning business cases out there that's the best option, is to turn it into an additive part. However, the most successful production benefits have really been utilizing the technology as an enabling performance benefit. So either from lightweighting the parts, Anne talked a lot about DFAM and designing for additive manufacturing, looking at it from thermal management benefits, reduction in part count, and even when you look at reduction of part count, right, there's a portion of you're reducing the part count, so hopefully you're reducing the cost, but you're also reducing the inventory management and a significant amount of qualification, steps that you no longer have to do. So you do have to look outside the box, I guess, for the true benefits to additive production. Some of the barriers, I would say, it can be cost. We're still there has to be a step change in either the productivity of the machines or the cost of the machines in order to see these large high volume benefits to to additive production, you know, in aerospace as well as other industries as well. When we take that into account and we start to really streamline the process and bring the cost down, that's when we'll see a lot more of the business cases come through. We also need to, you know, have the customer base that is identifying these candidates really being willing to take the step into a design for additive part, right? Be willing to train the engineers from the beginning and, you know, not look to just design something that is a cast part or a wrought part that we're also able to make it additive, but only make it additive and see the full benefits to that. It's, you know, there's a risk to that too, of course, and, you know, being in aerospace, it's not a risk that we're all going to be willing to take immediately, but when we are able to take those risks, that's when we'll see the best benefits.
Yeah, thank you. So really try to instill that confidence in the customers in order for them to really jump into the technology. Steps could be taken in order to instill that confidence in our aerospace OEMs. Maybe that would be a question for both Caitlin and Scott.
Sure. I mean, I think a lot of the collaborations like we do here are important steps just to make the connections. You know, we working collectively as a team, we can get a lot more done than if we're working in silos. So, and I know Scott can probably attest to that as well. It is still such a small community that when we can work together on things and just be proactive in that way, it's helpful.
Yeah, definitely. I could add to that, you know, I've talked to many people about this in the past, but, you know, I think the additive industry, as far as service bureaus or, you know, if we want to call ourselves contract manufacturers, you know, the additive world is so small right now that we tend to get caught up in thinking that we're, you know, mature already and we're a large enough industry, but the reality is we really aren't. And, you know, I think really the companies who are trying to push this forward need to work better together because we still have to build, you know, a mature marketplace for our technology. And the more we work together, the better that can be. You know, certainly things like, you know, design allowables, standards, specifications help us build confidence in our customers. But the more we work together, the better we build this market, the more customers who haven't come to the table yet will feel better about doing that. And then the full production that we're all looking for, you know, will be achieved.
And I think it's also important to note that, you know, we seem to hear the same thing over and over, even for the last, you know, 5 years as we've come together as an industry. But there have been a, you know, significant amount of changes, right? So although we continue to hear this, we have to collaborate, we have to work together. I think there have been good consortiums and good work done by, you know, contract manufacturers, working with contract manufacturers, working with powder suppliers, and working with the R&D and national labs to get a lot of good work done. And, you know, we can see the progress of that. You know, every day we see a success story about additive, and that's a testament to the hard work that people are doing, for sure.
Yeah, great. And then looking at it from the other side, so from an aerospace OEM, and what can AM companies do to make the technology more attractive and accessible to aerospace OEMs?
There's a couple of things that, you know, if you work in an additive layer manufacturing companies, and, you know, yes, it is important to engage with, you know, companies like Rolls Royce and see what we do and really understand what we do, and think about how additive layer manufacturing can really benefit, you know, company like Rolls Royce, for example, or any other companies in the aerospace industry. And I think to make it more accessible, you know, to me, from my personal point of view, the very first thing you have to think about is cost, because as you know, like, you know, the whole industry has been hit very hard by COVID. Right, and according to, you know, expert, it's going to take a number of years, probably 4 years, for the whole industry to recover to, to the level before COVID. And a lot of companies at the moment in the aerospace industry are struggling, just to survive, not to mention to thrive in this environment. So a lot of companies like Rolls Royce, for example, when it comes to investment, when it comes to, what we're gonna do at the moment to make us more competitive in the future, we really need to think long and hard about what technology we want to invest in at the moment. We can't just just invest to things which is nice to have. It has to be business critical. It has to bring real benefit to the business and to the company before we can put ten of thousand or 100,000 investment into this technology. So I think cost is, to me, is one of the biggest factor if you want to make it accessible for companies in the aerospace industry at the moment. And also the other thing I can think about is, like I said before, a lot of companies in this particular industry are very conservative, very traditional, and the people who work, the workforce, I think a lot of people still look at additive layer manufacturing as a very fancy future technology. They don't see that the technology has been around for many years, and we can actually utilize the technology to make a lot of things that we're doing today better, quicker, with less cost. So I think it is important to open people's mindset, to change people's mindset, how they look, how they perceive about manufacturing, about additive layer manufacturing. And I think in Rolls Royce very well in the last few years. So when I joined the company like 6 years ago, if I walk around Rolls Royce, see any 3D printer, but if you go to Rolls Royce today, I bet if you go into any room or any department, any office, you probably see 1 or 2 3D printer, like desktop 3D printer lying around, because people start to see the benefit of the technology can bring to the business, to the company. And it's quite funny though, because I spent over 1.5 years working in one of the Rolls Royce facility in Hucknall, right? And in the past, when we need a new tool, a new fixture, for example, to produce a part, the most common questions that people would be asking is, how much it's going to cost, how long we would have to wait for the tool to arrive. But if you ask everyone today, right, the first question that people are going to be asking is, can we print it? Can we print it in this material, that material? How many days it's going to take to print? And, when we're going to start using the tool on the shop floor. So you can really see that, people have changed their minds steadily. I think there's still a lot of things that we need to do, particularly for you guys. If you work in an additive layer manufacturing, if you're making the printer, if you make it, if you're developing this technology, and think about the thing like, can it be cheaper? Can you give us more case study example to really show us what the technology can do for company in the aerospace industry, because we really need that at the moment. So yeah, I think to me that's the 2 key points that I want to talk about.
Yeah, and I suppose in aerospace as well, it's not necessarily just the cost of the machines, the materials, and the production, but also the certification on top of that makes it extra difficult. So Caitlin, back to you. What strategy have some of your most successful aerospace customers used to embrace and advance the additive manufacturing technology?
I think honestly, it's been truly like a top-down commitment to the technology, and as well as a bottoms-up passion about it, right? So you have to kind of combine the two together in order to be the most successful. So when you do have CTOs and executive directives to get a certain amount of additive parts into a system, and not make it purely about cost, but really pushing the technology forward, it's been successful. I also think that it's really important to train young design engineers who are coming into like aerospace structure that is saying this is how you design a chamfer, this is how you design a clevis holder, whatever it is. making it available to them to also learn how to design for additive, and pushing them to think outside the box as well is really helpful, because when those designs end up on a print, and contract manufacturers, service bureaus, etc., take a look at them, it's very clear and easy for us to see, has this been designed for additive, or has it been a designer that has wanted to design for additive with a few rules of thumb, but they haven't been given the opportunity to really dig into it. So I think the most successful teams have been, again, it's through the whole chain of being able to enable the technology to allow us to see the benefits.
Okay, perfect. Thank you. Just a little reminder before we keep going, that there is, if you have any specific questions, feel free to drop any questions in there. So my next question is moving a little bit away from the strategy, and I want to come back to one of the points, Caitlin, you made about thermal management as one of the benefits. Do you or Scott maybe have an example of a project where thermal management was used, and how the benefits were used in order to manufacture that part? I know thermal management is something that's very important in the aerospace sector.
Sure. I mean, I can't personally go into details. Maybe Scott can go in a little bit more. But yeah, heat exchanger design in general is a huge opportunity in additive in aerospace and in defense. And I certainly have experience with a few very successful products that aren't just on the test a test box somewhere, but actually integrated into systems. And it's there's significant benefit there. I'll let Scott chime in as well.
Yeah, I mean, at CAM we really service two verticals. So turbo machinery, mostly for the space launch industry, and then also heat exchangers. So we have probably about 50-50 in our business of those two component types. And so with heat exchangers, there's a lot going on, not just in aerospace, but in many different markets. But I mean, like Caitlin said, I can't talk about exact applications, but commercial air flight is looking at heat exchangers and additive. Definitely in helicopters and fighter jets. A lot of chassis. With a lot of chassis that used to be built as just frames that receive heat exchangers or cold plates. Those are having now integrated lines within them for cooling in the chassis themselves. So, a lot of the advancement in technology that we're seeing comes from the use of additive in these heat exchanging applications, which makes the package smaller because, we can get more cooling out of them. And then that means more hardware can be added to the vehicles. And so there's a lot of things, in the drone world and in fighter jets and things of that sort where, we're seeing more and more technology. So yeah, it's, additive. I mean, heat exchangers is kind of the low hanging fruit for additive right now. Because, there's been a lot of talk in this talk today about cost. And certainly that's, as I'm listening to everybody talk here, I think about, why fix it if it's not broken? That comes to mind. And, I think that's how a lot of purchasers look at products, right? If brazing, for instance, we're talking about heat exchangers, brazing is a accepted evil, let's say, with heat exchangers. And that means, the reason I say it that way is because it works. It doesn't work well, but I can get my parts, right? And so purchasers who understand the lead time and the fallout and the cost that's associated with that, they've come to accept the understanding of the loss that's involved, and it's just part of the product. Whereas with additive, we have such a low failure rate, and our product is a much better, more homogeneous piece because of the way we build parts. We don't have the brazing problems, but the purchasers really don't see the value in that because quite you know, quite honestly, many times we're either the same, if not maybe a little bit more expensive than the product they're already buying, and they just don't see the value. So back to Caitlin's point, you know, it comes from the top down. Is, you know, it really takes leadership within the companies who want to buy additive, who understand additive, to push down to the procurement groups to say, even though you don't see the perceived value, and, you know, they're really looking at cost alone, it needs to be pointed out to them that there's more value than just the price alone. And it's not just lead time. You know, there's failure, there's life cycle, there's a lot of other values that are involved. And many times it's so hard to see that in a quote. So, you know, as Caitlin said, that is happening. But in order for this to happen more, we need more help from the upper leadership within these companies to push down to procurement to see the value in additive.
Yeah. And I guess, yeah, it's a bit of an issue like you spoke about. It needs to be used more in order for it to develop more, but then no one wants to be the first one to really, yeah. All right, perfect. I have one last question before we go into the Q&A. I saw that there was a few questions that have been asked in there. So if we look into the future, say 20, 30 years from now, let's say cost isn't really an issue anymore. What kind of new strategies or business models do you see with additive space in additive manufacturing in aerospace? So how big of an impact do you think it's going to be for the future of commercial aircraft?
Oh, I mean, I think Ann will be able to talk about this more, but I mean, for what I've seen from a purchase side, you know, in making components, I mean, aerospace is already the largest impact. You know, what we're seeing, I see another question in the questions and answers, but, you know, in the space and satellite world, you know, really aerospace and space and satellite is, you know, what I'm seeing is the largest users of additive today. You know, I mean, it's just you know, with the space side, the qualifications are lighter. The specifications are, you know, less stringent. I think they'll get there. You know, right now we're not involving, you know, humans on flight, so the specifications are lower. But as we get to passengers and, you know, we start to work in that area, you know, obviously the standards and specifications will be more necessary. But, you know, space is really leading the way right now as far as usage in additive. Aerospace always has been. I mean, it's been, you know, metal additive has been aerospace from the start. And we see a lot of advancement from that. I mean, we really, the additive industry has, you know, really needs to thank the aerospace industry, because it's really what turned metal additive from being a rapid prototype solution into a production viable solution. So, you know, they're definitely leading the way, and space has come along to really help drive that even more.
Perfect. Thank you. So we have about 15 minutes left. There's quite a few questions, so we'll get through what we can. So the first one we have here is maybe one for Anne. How to qualify new additive manufacturing alloy for aerospace application, particularly for the engine parts?
Right. How to qualify new additive manufacturing alloy for aerospace? I really don't know the answer for this question, if I'm being honest with you. I don't know if either Kathleen or Scott can help me here, but yeah, well, like I said before, you know, there's so many areas at Rolls Royce that we are, you know, using the technology, and we are developing the technology. And because, you know, there's so many areas, there's so many teams who are working on it. And unfortunately, I'm not in the team, you know, who pushing the boundary of material, you know, to use new material, new alloys for our engine parts. So if I'm being honest, I don't know the answer for these questions, and I don't want to mislead you or any of the audience if I don't know the answer. So unless Kathleen or Scott knows anything about that, please.
Yeah, I can help out with this a little bit.
Yes, thank you.
Actually, it's not as complicated as most people think. You know, maybe 7 years ago it was. But with all of the work that the ASTM has done NASA's been involved, NIST has been involved. I mean, there's a lot of work that's been done by SAE. So the standards and the qualifications that are required to be able to work with additive, they've been developed. If you look into ASTM, there's, installation and qualification standards already. It's a common question. This comes up in almost every single talk. And it does seem complicated. If you venture out on your own, it's going to take you several years to understand and qualify these systems. There's so many variables to look at, to characterize, to understand throughout the process, and it can be overwhelming very quickly. But that's what we've done. As Caitlin said earlier, we've all worked together over so many years to really figure out how do we add confidence or create confidence in this technology, and it's been done. So it's really not that hard. I mean, companies like CAM can help walk you through it. Carpenter has, from the powder side, can help from that as well. I mean, everybody involved in production additive for metals at least has methods and standards and specifications that we work to for qualifying for flight hardware. So I would say contact any one of the organizations who's involved in production, and we can help you with that.
Yeah, and I'll add, I guess I'll add being able to have, experience from an OEM at Pratt & Whitney and a contract manufacturer, and now a material producer. It can be complex, right? Can be overwhelming when you look at it from the very beginning, but, we do have structure in place, and we do have, even if you just look at a standard TRL, MRL development at an OEM, it tells you how to bring any new technology or any new system through those gates and through those milestones. So what I've been able to see is, there's things that the OEM has to do to, in their systems and their engineering standard work to make sure that they're looking at the right things. There's things that the contract manufacturers have to do, and that stems a lot into the industry standards of how to qualify the machine, how to qualify the laser, how to qualify the operation system. And then from the material side as well, right? We're learning what knobs to turn to continue to have that consistent raw material supply. And, are there standard materials that we can optimize for additives, right? So a good example is that, we've been able at Carpenter have been able to take a Ti 6.4 alloy and optimize it just enough to reduce the oxygen level and increase the strength. So things like that, when each of the what you would consider silos are working together, you could take this overwhelming program and actually be very successful with it. So, I think as we continue to engage with each other, it's something that we can work together on.
Perfect, thank you. And just to roll off that question quickly, who is responsible for qualifying new materials? Is it the manufacturers, is it the OEMs, or is it standard like ASTM, for example?
I guess it's probably on who you ask, but the reality, right, is that the material manufacturers and the contract manufacturers are not the design authority, right? So if the person and the company that has to put their name on the print is I believe is the ultimate entity that's responsible. But there's a lot of players in that, and there's a lot that goes into it, because they're not living additive day in, day out. They're living aerostructures day in and day out. So there's a lot of, we have to take it on ourselves to be responsible as well, so that they can have the confidence that they need.
Absolutely. All right, let's move on to the next question. What are some advancements made in spaceflight and satellite technology utilizing additive engineering? So I know, Scott, you touched on this
like
quickly.
Internal cooling and nozzles is a really big area for that. A lot of these startup rocket companies have really pushed the limits on design. They're getting much more thrust than ever was capable out of the same size engines. And a lot of that comes from the additional cooling capabilities that additive can provide to simply the design of the nozzles. If you look at, you know, the combustors in the area around that, there's so much as far as lightweighting and additional cooling that's happening throughout these rocket engines that really has reduced, you know, there's a term in the industry called buy to fly. And, you know, additive is a really large in reducing that buy to fly. And so that makes payload, you know, with the lightweighting, you know, the larger payloads that rockets are able to carry is because of, you know, both of these factors of lightweighting and the additional cooling. You know, so there's so much more performance, and with that extra performance, you know, it can carry the lighter vehicle. So much more payload is available per launch, which is driving down the cost in the industry for the users there.
Perfect. Thank you. Next up, we have, in which industry do you think additive manufacturing will have the greatest impact in the future?
I've been seeing that question and I wanted to make a comment. So the industry that's going to have the largest impact is the one that puts the most energy into the technology. And so far that's been aerospace and the rocket industry. But, you know, it very well could be automotive. I mean, whichever industry decides to really put their foot forward and drive the technology and use the technology and design for the technology is the one that will take the most benefit.
Yeah, perfect. That's a good answer. What are the main costs for additive manufacturing? Is it material? Is it machine? And something we haven't spoken about yet, post-processing.
I mean, I think that those are the main drivers, right? So material, obviously, and you know, if you look at all of the aspects that go into a component, that's where your costs are going to be. So you know, you have your material, you have your machine cost. Every minute that machine is down, it's costing more money, right? So downtime, either preventative maintenance or unplanned downtime, or even just time to you know, sieve the powder that you can't get it back into the machine fast enough. All of that is costly. Post-processing, you know, it is one unfortunate circumstance that happens when we get a part that, you know, is potentially a great additive part, but the customer base doesn't necessarily realize how much goes into the post-processing. And not only are we, you know, having to do machining and figuring out datum schemes, and, you know, some very high-tech CNC equipment is often needed for these organic shapes. But even just down to material selection, are you picking a material that has a super expensive heat treatment process? Are you picking a material, or are you picking a structure that, you know, that isn't easily nested into your build layout? You know, so there's a lot of components to it, and working with contract manufacturers and experts can really help you take any application and drive out costs with lots of different knobs.
Yeah, I think I just want to add to Kathleen. So from my personal point of view, I think, you know, it is a very tricky question to answer. And I think it entirely depends on your application, because, you know, there's so many technology available today when you talk about additive layer manufacturing. So, you know, if you just want a quick prototype, then you can think about like FDM, SLA example. But if you want a high-end production parts, then you need to go into, you know, much more sophisticated technology like SLS or whatever. So, you know, I think really it depends on what application you want your parts to be, what the functionality of your parts. Then, you know, it's bad to go and have a chat with, you know, the expert in the industry. For example, like Scott or Kathleen, for example, then, you know, they should be able to advise you, you know, based on what you want, what you need, what your application is, you know, what's going to be the best material or the best technology that, you know, you can use to produce your parts.
Yeah, perfect. Thank you. We have 5 more minutes left. We probably have time for 1 or 2 more questions. This one is for Scott. So you mentioned design allowables for 3D printed parts. Could you elaborate?
That's a tough one. you know, as Caitlin said, you know, most of, you know, this goes back to the onus and who qualifies the process. So most of the allowables that are truly fully functioning allowables are really owned by the OEMs. So, you know, people like, excuse me, Lockheed, Honeywell, NASA, those are the people who hold the true allowables right now. I mean, obviously, you know, MMPDS is where it's at. And many of the allowables are, you know, there now. You know, aluminum and Econel 718 are both materials that have been, you know, fully developed at this point. So, you know, I would urge you to go to, you know, their websites and look at that. But NASA is working with Auburn University right now, and they are specifically working with, you know, the ASTM Center of Excellence for exactly that, to build allowables. So, you know, I would look at the NASA developments in Auburn University, and then, you know, contact people at ASTM to look into that. I put my email address out there. You can email me. I can help with that more. But it's an industry thing right now where people, it's not the people who truly have the allowables. It's hard to get them. But the point is, we're really close to having them publicly available, and NASA's pushing for that.
Perfect. Good. Next question here is there any study on the application of printed parts on aircraft and on the stress and fatigue to which they are exposed?
Yeah, there's tons of studies around that.
I'm hoping.
You know, I mean, if you just Google what you just said, I mean, you're going to get a lot of it. But, you know, an easy place to look at that would be the GE LEAP engine. There's several applications around that, and they've been pretty public about a lot of the work they've done. You know, fatigue is kind of the scary question for us all. And I don't say scary because it doesn't do well, but it's extremely expensive to test. And it's what comes up in every conversation is, you know, how does additive work within fatigue? I'll tell you, with, you know, especially when hipping parts, our microstructure is identical to the billet rot properties and microstructure within those materials. So anything that you would expect out of a billet part is what you can get out of an additive part. Now, like Caitlin said, there's definitely post-processing that is the same, but there is a little bit more that's involved in additive. And I don't mean more in that it is necessarily more expensive. It's just different. But as long as you treat the parts properly, you post-process the parts properly, you can achieve the same results as you get within billet parts that in additive parts.
Yeah, and I'll mention, I guess, to that a little bit more. You know, and I think Scott was alluding to it. The surface finish of these parts, obviously, when they come out of the printers, can be pretty rough, right? So often we have customers will put on, you know, a 250 RA all around because that's what the castings normally were, and it's an option that they can get, you know, quickly to the finish line. However, again, when we try to pair cost versus requirements, you know, you have to ask yourself, do you really need 250 all the way around, or do you need a 63 RA in this high stress, you know, radius location, and you're okay with a grit blast finish everywhere else, right? So when we're looking at through the whole value stream, right, we need to look at the part print even and zone the part effectively for the post-processing that we have. And, you know, I think that a lot of the OEMs have done some great work with taking, you know, as-built specimens, and they test some of them in a truly as-built condition. They test some of them in a chem etch condition. They test some of them in abrasive flow condition, you know, and different media blasts, and that's where all of the material allowables information comes from, and that's where their knockdown factors come from, and all of that standard work is truly, you know, inside the meat of the OEMs, and you know, that's where they've been successful in figuring it out.
Perfect. All right. Unfortunately, we've run out of time today. But thank you so much, Anne, Scott, and Caitlin again for joining me on the panel today. If we haven't gone to your questions, I'm sure they will hang around for the rest of the day, and you can go find them to ask any further questions. So thank you again, everyone. Thank you for your questions.
Thanks.
And I will speak to you all soon. Thank you.